Alright, welcome back to the discussion for 10.3. This is on matrices, and I have a very small board which is going to make this discussion require me to do a lot of erasing, so get ready for your pause buttons if you need them. But let's start here on number 11. Number 11 is, I've already written it here, and it asks to find the solution, the xy value that solves, the xyz value that solves this system of three equations. So the very first thing that I would do with this is to rewrite it as a matrix, and that is just to grab all of the coefficients. So 1, 2, negative 2, 2, negative 3, 1, 5, negative 2, 1, and then augment it with the solutions on the right of negative 3, 8, and 9. So that looks like this. We'll write a matrix, just opens up with a big left parenthesis or a bracket. And again, just those numbers, 1, 2, negative 2, 2, negative 3, 1, and then 5, negative 2, 1. And I augment it with, on the right hand side, negative 3, 8, 9. Okay. And then I'm going to go through a process to, it's called the Gauss-Jordan, I'm going to go through the Gauss-Jordan elimination. Gauss goes through and just gets ones across the diagonal and then zeros on the left, but then Jordan said, well, why not finish this up and do the rest of it? So I'll do that part, but the idea is to start in the upper left and get a 1, and we already have that, so we're set, right? And then after you get that 1 that's there, I would eliminate this 2 and the 5 by using that 1. And so that is to say, I'm going to take negative 2 of row 1 and add that back into row 2 to become my new row 2. And likewise, I'll take negative 5 of row 1 and add that back into row 3 to become my new row 3. Because of this 1 here, that makes this work. Negative 2 times that 1 is negative 2, and if I add that back into this 2, it gives me a 0. That's exactly what I want, but I have to do it for the whole row, right? So let's do that. The first row is not being changed, so I'm just going to rewrite it. 1, 2, 1, 2, negative 2, negative 3. Okay. Now I need to go through and do these operations for the second and third row, so let's do this. Negative 2 times the element here in row 1 is negative 2, plus that element in row 2 is negative 2 plus 2 is 0. That gives me exactly what I was looking for. Negative 2 times this element in row 1 is negative 4, plus negative 3 is negative 7. Negative 2 times negative 2 is a positive 4, plus that element from the second row, it's positive 4 plus 1 is 5. And then negative 2 times negative 3 is a positive 6, plus 8 gives me 14. These are getting kind of squished together here. There we go. And I do that, of course, for the third row as well. Negative 5 row 1s plus row 3, so negative 5 times 1 is negative 5, plus 5 is 0. Negative 5 times 2 is negative 10, plus negative 2 is negative 12. Negative 5 times negative 2 is a positive 10, plus 1 is 11. And negative 5 times negative 3 is a positive 15, plus 9 is 24. Great. So step 1 and 2 are done. Step 1 was to get the 1. Step 2 is to eliminate everything else in that column. The next one is to turn this negative 7 into a 1. And then after that, use it to eliminate the things above and below it, right? Now, there's a little bit of clever manipulation that can be done, right? Because I could just divide everything in this row by -7 and I would get a 1, but I would also get terrible fraction right here. I don't really want that, right? I can do it. If I'm not afraid of fractions, run with it, right? But then every calculation from here on out potentially has something with a 7 in the denominator, and that's rather unpleasant, right? But instead I'll note that, let's look at our 7s. 7 times 1 is 7, 7 times 2 is 14, 7 times 3 is 21, 28, and 35, okay? And I'm going to look at my 12s, my multiples of 12, 12, 24, 36, and I found two numbers that are 1 apart from each other, right? And I can use that, because 3 times 12 is 36. If I multiply this bottom row by -3, to get rid of this negative, I'll have a 36. But then if I add 1, 2, 3, 4, 5 multiples of row 2, that's adding a 35, that'll give me a 1, right? So it's a little bit of clever manipulation. Solely, the only reason I would do this is to avoid having 5/7 hanging out here in order to do some horrific calculation in the end, right? So that's what I'm going to do. What I've just said right here is I'm going to take 3 row 2s, and I'm going to write it over here because I'm going to do some math. 3 row 2s, -3 row 2s, that is. And then I'm going to add 1, 2, 3, 4, 5 row 3s. Oh, I'm sorry, that's -3 row 3s. And I'm going to add 5 row 2s. Right? That's what I want. This is a little more complicated than what I did up here. Here I multiplied a row by a number and then just added the number that was in the other row. Here I have to multiply both. It might get a little confusing. So I'm going to do this out. I'm just going to take and write -3 row 3. So -3 times 12 is 36. -3 times 11 is -11. -3 times 24 is -72. No, it's not. It's embarrassing. 24 times -3. Yeah, it is 72, and it's negative. Okay. And then, of course, 0, right? So this is -3 row 3. And I just need to add on 5 row 2, so I'm just going to take 5 times 0 is 0. 5 times -7 is -35. 5 times 5 is 25. 5 times 14 is 70. And I'll just add these two, and that's my new row 2. So I get 0, this is 1, 25 minus 11, 14, and then minus 2. So this is what's going to take place of row 2. I'm going to have to erase some stuff because I'm out of room here. It probably won't be the first erase, but here we go. So I didn't mess with row 1 or row 3 over here, so I still have 1, 2, -2, -3. Its row 2 is now 0, 1, 14, and -2. Okay. And then my row 3 I didn't change. 0, -12, 11, and 24. And the nice part about this process is once I get a 1 in the right place, I can use that 1 to eliminate the rest of that column. So that is to say, I'm going to take -2 of that row 2, where that 1 is, and add that back into row 1. And likewise, I'm going to take 12 of them, 12 row 1, 2s, and add that to row 3. Okay? Now I'm going to erase this because I'm eventually going to need it, so here it goes. Okay. All right. When I do this, again, this middle guy is not being affected, so it stays as 0, 1, 14, and negative 2. The top one is negative 2 row 2's plus 1, row 1, so negative 2 times 0 is 0, plus 1 is 1. Negative 2 times 1 is negative 2, plus 2 is that 0. Negative 2 times 14 is negative 28, minus 2 more is negative 30. And negative 2 times negative 2, I feel like this is wrong. I might have to double check this. But negative 2 times negative 2 is positive 4, minus 3 is 1. It's either wrong or z is 0. But I guess we'll find out. Okay. And I'll do the same for the bottom. 12 row 2's, 12 times 0 is 0, plus 0 is 0. 12 times 1 is 12, plus negative 12 is 0. 12 times 14 is a friggin' lot, 144 plus 24 more. And then 12 times negative 2 is negative 24, plus 24 is 0. That confirms here that z is indeed 0 because 168 times z is 0. That will be my next step, though, is to turn this 168 into a 1. I can do that by multiplying by 1 over 168 or dividing by 168. Either way, this is going to turn into a 1. The rest of that row is zeros, so that tells me that z is 0. So I have one of my three solutions. Z is 0. But again, I have a 1 in the right place, so I can use that 1 to eliminate the rest of these things. But that's not going to change a whole lot. I'll just take 30 row 3 and add it to row 1. And I'll take negative 14 row 3 and add it to row 2. But again, because it's a 0 hanging out here, you won't see a lot change here. 0, 0, 1, 0 stays the same. 30 row 3 is 30 times 0 is 0 plus 1. 30 times 0 plus 0 is 0. 30 times 1 is 30 plus negative 30 is 0. 30 times 0 is 0 plus 1 is 1. 14, negative 14 times 0 is 0 plus 0 is 0. Negative 14 times 0 is 0 plus 1 is 1. Negative 14 times 1 is negative 14 plus 14 is 0. And then negative 14 times 0 is 0, plus negative 2 is negative 2. And I have my solution once I have that diagonal of 1s. X is 1, y is negative 2, and z is 0. Is that the only way to do it? No, certainly not. But I did it, so it's the best, right? Anyway, let's take a look at the next one, which was number 13. My black is running out, so I'm going to switch to a blue marker. Hopefully you can see it all right. Wrong way here. There we go. Okay, 13. I'm going to skip translating this from a system straight into a matrix. So number 13 says we would get the matrix 2, negative 1, 3, augmented with 0, negative 2, 1, negative 4, 3, 1, negative 2, 4, and negative 6. Okay. Now step 1 is to get that 1 in the upper left hand corner. One of the things that you can do with a matrix is swap rows. So I'm going to take row 1 and row 2 and just switch the places. Excuse me. Alright, so I'll write this one up top. And without having to do any algebra, I've completed step 1. I got a 1 in the top left. Okay. But like always, if I get that 1 in the right place, I can use it to eliminate the rest of these. So I'm going to take 2 row 1s and add it to row 2, and I'm going to take negative 2 row 1s and add it to row 3. That gives me the top unchanged, 1, negative 2, 4, and a negative 6. 2 row 1s plus row 2, so 2 times 1 is 2, and negative 2 gives me 0. 2 times negative 2 is negative 4, plus 1 is 5. Ha! 2 times negative 2 is negative 4, plus 1 is negative 3, because math is hard. 2 times 4 is 8, plus negative 4 is 4. 2 times negative 6 is negative 12, plus 3 is negative 9. And then negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 2 is a positive 4, and a negative 1 is a negative 3. Is 3. Nope, it's negative 2 and negative 1 is negative 3. Alright. It's easy because you're doing so many small calculations to mess something up, so be careful. But negative 2 times negative 4 is a positive 8. Plus 3 is 11. Okay. And negative 2 times 3 is negative 6. Plus 0 is 0. I did that bottom row all wrong because I messed it up and did it with row 2. So let's just back this dumpster fire up here. Make sure I did row 2 right. 2, 0, 4, negative 3. That's 8 and 4. And that one's negative and it's 12 and 9. Alright, row 2 is okay. Row 3, I started messing with the wrong row. I did 2 times row 2. Here I want to do negative 2 times 1 is negative 2, plus 2 is 0. Negative 2 times negative 2 is a positive 4, and a negative 1 gives me a positive 3. Negative 2 times 4 is a negative 8, plus 3 is negative 5. And then negative 2 times negative 6 gives me a positive 12, plus 0 is 12. Alright, I think we're on the right track now. Okay. Now, I want to get a 1 here, but I can't really do it without getting a fraction. Because I can't mess with the guy above it, because if I do, I'm going to introduce a 1 back into this column. I have a negative 3 and a 3. They're the same number but different signs. I can't multiply one by something and the other by something else and get them 1 apart. It's not going to happen, right? So what I'm going to do is kind of ignore that guy for a minute and go to the next one. I want this negative 5 to be a 0, or excuse me, a 1. And so I'll do that. I'll take this. I'm going to change its sign to make it positive, right? I'll even write it out here, just so we can see step by step what's going on. Change the sign of the bottom, so just multiply everything by negative 1, so I get 0, negative 3, or and then a 5, and a negative 12. Because 5 and 4 are 1 apart, so I'm going to take row 3 and minus row 2 to give me my new row 3. Right. So, row 1 is not being affected. I still have 1, negative 2, 4, negative 6. Row 2 is not being affected, so I still have 0, -3, 4, -9. And I'm taking row 3 minus row 2, so 0 minus 0 is 0. -3 minus -3 is 0. And then 5 minus 4 is 1. And then -12 minus -9 is the same thing as -12 plus 9. That's -3. Now that I got this 1, I'm going to use it to eliminate the rest of that column. So I'm going to take -4 row 3's and add it back into row 1. And again, -4 row 3's and add that back into row 2. So row 3, in fact row 3 is done because it's 0, 0, 1, so z is -3. I'm not going to mess with row 3 again. But eliminating these, -4 row 3's plus 1, well -4 times 0 is 0, plus 1 is 1, -4 times 0 is 0, plus -2 is -2. The only one it affects here is this, -4 times 1 is -4, plus 4 is 0, and my solution. -4 times -3 is a positive 12, plus -6 is 6. -4 times row 3 plus row 2 is -4 times 0 is 0, plus 0 is 0. -4 times 0 is 0, plus -3 is -3. -4 times 1 is -4, plus 4 is 0. And then -4 times -3 is a positive 12, plus -9 is 3. And now it's easy to get this last one that we skipped, because all I have to do is divide this by -3. Or times it by 1 over -3. I'm going to divide it by -3. I need the room, so the top 2 layers here are going away. The only thing I'm affecting is row 2, so row 1 stays as 1, -2, 0, and 6. Here I'm dividing by -3, so I get 0, 1, 0, -1. And here 0, 0, 1, -3. We can see we already have y and z. Y is -1, z is -3. The only thing I have left to do is to use the one that I just got and eliminate this -2. I don't have to play with the other guy because it's already a 0. So I'm going to take 2 row 2's and add it into row 1. And I'll be done. Row 2 and 3 are the same. 1, 0, 1, 0, -1, 0, 0, 1, -3. 2 row 2's plus row 1 is 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus -2 is 0. 2 times 0 is 0, plus 0 is 0. The left hand is exactly what I want, the diagonal of 1's and nothing else. 2 times -1 is -2, plus 6 is 4, and so my solution is x is 4, y is -1, and z is -3, unless I screwed up, but I hope I didn't. Let me throw it in here just to check. 4, -1, and -3. And that's 13, so I've put in my answer and it says I've submitted the homework. I got an F because that's the only question I did. But it's right, so it looks like it's all good. Alright, hopefully that was helpful. I know matrices are not everybody's favorite. If you are like an engineer or if you are going into math, any of the STEM fields, they're not going away. So, you know, maybe spend a little more time on this section to understand them if you don't, if you are going to need them. But I will see you guys next time. Thanks.